Assalamu alaikum students. Today I am with another topic of physics of class 12th, which is Einstein's photoelectric equation. Einstein in 1905, Mr. Einstein, he gave an equation which is called as photoelectric equation, and for it he was rewarded the Nobel Prize. What he did, he proposed a theory by he used Planck's Planck's quantum theory of radiation. He used Planck's quantum theory of radiation to explain PEC, photoelectric effect. According to Einstein, what I will say, if this is a metal surface, now on this very metal surface there is incident of photons, H nu. Now there are electrons within this very metal surface. According to Einstein, according to Einstein, what? The energy of this incidental photon, energy of incidental photon is utilized into two processes. What are the two processes? First one is this very photon of energy E is equal to h nu is incidental on this very metal surface. What will be its first purpose? The first purpose of this very photon is to take the electron from within the metal on the surface of metal, which we have read, which is called as the work function. So the energy of incident photon is utilized in two processes. What is the first one is which is called as the work function, to make to take electron on surface of metal. Brackets must in brackets will called as work function. Work function. What is work function? We have read work function is defined as the minimum amount of energy required to take the electron which is within this very metal surface within the metal to on its surface. That's called as the work function, which is denoted by phi. So one part of the energy is utilized, it is first absorbed by the electron, then after absorbing this very electron is going to move on the surface. At the second part, the rest part, the remaining part of energy, remaining part of energy of incidental photon is used to give kinetic energy to electron. Kinetic energy to electron. It's very obvious. Once you are having this very photon, let's make some example. If this very photon is having 100 joules of energy, I'm just supposing 100 joules of energy. Now this very electron takes 60 joules. Yeah, you have to say 40 joules. If it takes 40 joules of energy to come on the surface, so it utilizes 40 joules. So remaining, if out of 100 joule of photon, 40 joules are utilized to take the electron within the metal to on its surface, which is called as work function phi. Now the remaining 60 joules are utilized to give the kinetic energy to the photon. So this is the simple equation. By this very simple process, he developed an equation which we called as the photoelectric equation. There was an equation developed by him called as photoelectric equation. So therefore, we can how he developed. Then according to conservation of energy, there was 100 joules of energy. This very 100 joules are to be conserved. A part of it is utilized to for the work function process. A part of it is used to give the kinetic energy to the electron. So we can simply say according to conservation of energy, we will say what h nu is the energy of incident photon is equal to phi, the work function, plus kinetic energy 1 by 2 m into v square, where v is the velocity of the electron. H nu. H is the Planck's constant. Planck's constant, nu is the frequency, phi is the work function, m is the mass of electron, and v is the velocity of electron. So now we can say here, if nu equals to nu naught, what is nu naught? Threshold value. Threshold frequency, you have to say. Then is the electron going to move with some kinetic energy? No. That is no kinetic energy for electron. No kinetic energy for electron. So how will proceed here? If nu is equal to nu naught, then it will be h nu naught, just name it equation first, equal to phi plus this will becomes a zero, because there will not be any type of kinetic energy. No kinetic energy for electron. Because in threshold value, it is only the value, it means only you are having a photon of 140 joules, and those very 40 joules are utilized to take the electron to the surface. No kinetic energy. So using this very therefore, which implies phi is equal to h nu naught. Using this value in equation first, what we will get? We get, using this in here, here it will be h nu is equal to, instead of phi we will place it h nu naught plus 1 by 2 m into v square, or you have to say h nu minus, just take it here, h nu naught is equal to 1 by 2 m into v square. This equation is called as, this equation is called as Einstein's photoelectric equation. This is Einstein's Einstein photoelectric equation. So this is how we are going to derive the photoelectric equation. Simply, the concept is simple. The total energy given to the photon, given to the metal surface, it utilizes new process. One amount of it is used to take the electron within the surface to on the surface, and remaining, if it is having the remaining some energy, that is utilized to give the kinetic energy. And that is how we used the data, and we finally got this very equation. This very equation is known as photoelectric equation. This is the equation for which the Einstein got a Nobel Prize. This is all for today. Tomorrow will be with another lecture. Till then, Allah Hafiz.